What's up? I'm gonna be doing my two questions for week 3 right now. For the first one, I was gonna do question 1. A little bit simple, but I do like it just because it shows you two different laws. Um, a father and a 7-year-old daughter who have different masses are facing each other on ice skates. With their hands, they push off against one another. Which one or more of the following statements are true? Each experiences an acceleration that has a different magnitude, and each experiences a pushing force that has the same magnitude. And I'm going to explain this by drawing it here. Let's just say that this is the dad, and he's pushing off his daughter, which she's right here, and they push off of each other on little ice skates. Boom. And boom. Barely look like ice, but you get the idea. They're on ice, and they push off of each other. So this is Newton's third law, where for every action force has an equal and opposite reaction force. So if either of them push off of each other, the same amount's going to be pushed off the other, according to Newton's third law. And each experiences a pushing force that has the same magnitude. That is true. They would both have the same pushing force magnitude because of Newton's third law. Then for each experience an acceleration that has a different magnitude, this is due to their weight being different. For example, if the father's weight was 80 kilograms, then he would move 1.25 meters per second squared. It's not a 5. Now if the daughter was, let's just say, 20 kilograms, she'd be moving at 5 meters per second squared. So when each experiences an acceleration that has a different magnitude, that is true. They're both accelerating at a different rate. But when they do push off of each other, they both have the same pushing force, the same magnitude of pushing force because of Newton's third law. And now they're happy, now that they know physics. So that was question 1. Now for question 2, I want to do this one. A 103 kilogram baseball player slides into the second base. The coefficient of kinetic friction between the player and the ground is UK equals 0.589. What is the magnitude of the frictional force? And if the player comes to rest after 1.05 seconds, what is his initial speed? So let's draw this right here. This is the base. This is him sliding. Horrible picture. Boom. Little baseball bat. That's not a baseball bat. What? Anyways, that's his baseball bat. For now. So when he's sliding, he has his initial velocity, or he has his velocity here. This is just a force. And then he has his friction. There's his friction. His kinetic friction. And then we have the normal force acting here, and then the ground acting here. This is what it looks like. And we know that he's 103 kilograms. And we know that the UK is equal to, I have them all right here, 0.589. The time is going to be 1.05 seconds. And then the final velocity for the second part would be 0 ms, because we're going to be at a halt. So, since we're only looking at the horizontal forces here, horizontal forces here, we're going to be using one equation, and that equation is going to be F frictional force equals UK N, where in this case N are the normal forces, so it's going to be mg, which is the mass and gravity. So the equation is going to be UK mg in this situation. So now we just plug in from here. Frictional force, UK, the number we got here, the mass, which we have right here, and gravity, which is 9.81. So we want to insert these. Boom. Equals 0.589 times 103 kilograms times 9.8, and this would be equal to 594.7 newtons. It does come out to be newtons because this is a force. Now, let's check here. 595, we did round up, but that is the magnitude of the frictional force that is, that the magnitude of the frictional force that is on this player right here be 594.7 newtons, keeping him back. Now, if the player comes to rest after 1.05 seconds, what is his initial speed? So we want to find an initial speed. So in this situation, we want to use V of Vf equals Vi plus AT. So in this situation, final velocity, initial velocity, we set up here final velocity was going to be 0 meters per second, but we are missing something, and we're missing A, which is the acceleration. This is what we need to solve this equation, because we already have time. Already have the initial velocity. So we need to, no, we're finding initial velocity, and we already have final velocity, and we have time. So we're trying to find initial velocity, and we're trying to find acceleration. Currently, thank you. So if final, sorry. Yeah. So we're going to be using this equation. F equals M, A, and in this situation we're going to be looking for A. So F is the friction, M is the mass, A is the acceleration. We're going to be looking for A. So we're going to change this up into A equals negative the frictional force over M. We just plug in here. So negative the frictional force is going to be 594.7 newtons, this number right here that we got from part A. And then we're going to use the mass 103 kilograms, and this comes out to negative 5.77 meters per second squared. Now, question here is, why would this be negative? Why did it come out to be negative? Well, if we're thinking about it here, the frictional force in this situation is going to be negative. The frictional force is positive because it's a force acting upon something. It's not going to be a negative force. But the acceleration is going to have a negative connotation to it because he's not getting any faster because of the frictional force being applied to him. So because of the frictional force being applied to him, the acceleration is going to be decreasing at this rate. His acceleration is going to be decreasing at this rate. That's his speed. That's why it's going to be negative. He's not speeding up, he's slowing down. But what is happening? That's why it is going to be negative, if anybody was now wondering why it was going to be negative. So after we find this number, which is the acceleration. We could plug into this right here. Let's put it up here. So if v of f, if final velocity is going to be 0 meters per second, we're going to be looking for the initial velocity. So we're going to add negative 5.77 meters per second squared. And the time, which was given to us in the problem, 1.05 seconds. This would come out to be, it'd be 0 equals vi, which is velocity, plus I believe it was 6 point, yeah, it'd be minus, oops, let's get rid of that, minus 6.07, because the minus does cancel this at plus. So we're going to add this to this side, so plus 6.07 plus 6.07. Let's carry it on over here. 6.07 equals vi. So vi is equal to 6.07 meters per second. And that is correct here. If the player comes to rest after 1.05 seconds, what is his initial speed? His initial speed would be 6.07 meters per second. And this is the final problem. With everything solved out, all the units pulled out, every equation. Here's the picture. And he's making it to home base. At that rate, I don't think he's gonna make it to home base plate. Honestly, you could probably find, maybe if we were given distance, using the acceleration and the velocity, we could find out if he makes it to the base plate. It's pretty interesting. It's an interesting question. But that's going to be it for week 3. See you guys in the next week.